edition of our monthly technical training program. On behalf of J Cardinal Engineering Services Limited, I want to warmly welcome everyone joining us today. Especially welcome our Managing Director, Engineer J.T. Adeyemo, whose commitment to building technical capacity within our team continues to make this program a success. Today's training is on mining and quarry design part 3. Recall that the series began in May 2026, and because of how vast this subject is, it was structured into 4 parts. Today's session marks the 3rd installment, and I'm sure we'll gain valuable practical insights from the discussion of today. It is now my honor and privilege to introduce our facilitator for today's training session, a seasoned mining engineer. I call him accomplished industry general, and our managing director. Ladies and gentlemen, please put your hands together to join me in welcoming Engineer J.T. Adeyemo.
Thank you very much. The distinguished colleagues, technologists, and people online, other offices across the groups, and some are professional that are watching. So we began this series as partners and teams in mine design. It's part of very important subjects that can give us the success in any mining exploitation that we have to do. We have begun with it from series 1. We first analyze it, then as need, when the need arises, said we have to put it down for easy understanding of the subject matter. That is why we now say, okay, we have mine design 1, surface mining, then underground, then the relevant definitions that we made in this mine design. Now, we have exhaustively discussed the surface mining, the method used in designing it, and I believe today too, it also is advanced one that in our country of today is more that all prevalent, and people are very, very scared in going to it. But I can bet it today if you look at what we are going to do and you listen very well, or we do personal consultations. As far as mining is concerned, when all the norms, the rule of the tops are carefully followed, then we are good to go. Now, we are going to discuss exhaustively today how you can design an underground mines. And the meaning and importance of underground mine design is going to be discussed. All body evaluations and mining method selections, that is within the underground confines, access system and underground layout, then ground support, ventilation and haulage system in underground mining, and the water system, scheduling and software needed when you are designing the underground. Because at any levels, you are going to encounter water table, and what is your water process that is not going to be contaminated with what has been done, all the lot of iron and ions that's underground. So these are the process of the water system that you are going to watch. Now, let me commence by underground mine design is the process of planning the safe and efficient and economic extractions of all bodies located within the earth surface Unlike open pit mining, underground mining focuses on accessing deeper mineral deposits through shafts. These are one of the things that we use to reach the mineral body as they are shown there. We can reach through shaft sinking, decline, tunnel, stops, while maintaining ground stability and worker safety. Because all the design methods, the method used in the underground, what is very predominant and what is very important to us is how we safely do whatever we want to do. Because how the safety of the workers that was involved is one of the things that are paramount. And when you are talking about the SAT, the access design underground, so it's one of the methods. So we are going to look at it. When you say vertical shaft is an excavation driving straight down from the surface, provided the access, causing of the ore, waste, personal transport, and vegetation. So this is a vertical driving straight down from the surface towards the ore body. I'm going to design it, and it is a vertical down safely, through which all other things is going to translate. Then if you decided to use incline ramp, that is an incline turn, usually 1 to 7 or 1 to 9 gradients. That is when you use an incline to reach the ore body. It's either you use shaft, vertical, or you use decline ramp. The form of that has to be within 1 to 7 or 1 to 9 gradients. And driving from the surface of the underground, allowing the rubber tire vehicles and other trucks to drive directly into the mines. So those are some of the things that we use. And then all body evaluation. Consider the whole body geometry. Before you do the underground mining, you have to consider the whole body geometry, depth, thickness, grade distributions, and geotechnical characteristics. Important considerations: all thickness, deep and strike, road competence, depth, and grade continuities. We are going to look at it because if you want to design an underground, you have to look at the continuity of your discovery. The geometry, the geology will have shown us the geologies of that ore body. Is it the one that is continuous or the bucket size? And when you look at the bucket size, is it the one that has the high grade, that what of the economic value of sinking a shaft or create an ram that is declined, or using an adit, which is an horizontal or near horizontal tunnel driving into the hillside to provide direct access by the use of ventilations and natural drainage into the underground mines if you use an adit. So you have to consider the minerals that are there, what are the prevalence, what are the essentials, is it what of the economics you have assessed. The group of geologists that is under the mineral resource, they have discovered this. We look at the geometry. Okay, is it what was now to go underground because of the expenses of sinking a shaft, creating an adit, or creating a ramp, or we use ways or rails to be able to access that particular thing? Now look at it. Because if the oil grade is not continuous, or just a very little one, just discover that you going through it underground may not be economical viable. A reliable evaluation guide, method selections, and production strategies. So those are some of the things that you have to consider that when you, before you want to embark on underground mining. And we have another slide that we have the mining method selections. The selected method depends on your body geometry, as I've said earlier. Deep, the depth, rock competency. This is where the detectives have to assess what is the rock competency of the shaft you want to sink, because if the competency of the rock is not strong enough to hold the shaft or to hold the huddles, which can cause mine collapse, you will not be able to continue gains and economic values of what you want to do. The common method includes, not limited to the following: rooms and pillars, cut and fill, sublevels, stopping, block cavings, and shrinkage stoppings. We see for the diagrams the relevance of cut and filled, common underground mining methods as identified in the first diagram, that is cut and filled. The second one, sub-level stopping. Then the other one, block cavings. Then the last one is shrinkage stoppings. That is, when you mine, you fill. When you mine, you fill the area of hollow created to serve as support. Then sub-levels, you are going to be remove the ore discovery level by level, and at the same time, block caving, you are going to be giving it as block by block, then before you hold it, and string it as well through the process of mineral processing by stringes you design. Then you have now mine access and underground layout is another very important thing. How is it done? As we have layout in open mines, so also we have layout in underground layout as well. Mine access design. Access may include vertical shaft, as I've said. The shaft is the way that basically how you can reach your ore body, and decline or route, hadith, wings, and raising. Wings is an internal vertical or steeply inclined shaft sunk downward from the existing underground level to across the deeper one, while the raising is just internal vertical of inclined excavation driving upward. This one is driving upward from the lower level to a higher level used for ventilations. So it is very important that you consider that access design control movement of people, all equipment and staff, because you have to design how the trucks, both the articulated that are bringing in impulse, and at the same time you can create a rail system towards the mines, and at the same time you use how the equipment is going to have access to the mine. Then, as I've said, underground layout involve level, cross-cut, drift, oil passes, and loading stations. Those are some of the things when you are considering the layout. You design where that is, this involve levels. That is the comfortable levels of which all operations is going to be taking place. And at the same time, the cross-cut, where the cross-cut is going to be done. And at the same time, you are going to do the drifts, or then all passes and loading stations. Those are some of the areas you are going to be strategically located underground for your operations to be efficient and to go back. And when you are designing it, you should be able to know that this is the actual area where it's going to be loaded. And at the same time, in case there is a mine collapse, you are going to have a muster point, and at the same time, where all other activities will. Then the layout must optimize all the recovery, ventilation flow, and transportation efficiency. It is very important that when you are designing your underground layout, ventilation is very important, because this is going to tell how the poisonous gases that has related with a lot of things in the underground, how we are going to exchange and how the oxygen is going to come in and left the mine is very important. You are going to use the larger the mines and the type of the ore body. It determines how the type of ventilation you are going to do. The mine ventilation calculations is going to be taught. We are going to expose you to it in the next series. How do you know how many ventilation an underground mine deserve? Because it depends on how big and large a mine is, determines the number of ventilations, the outlet that this ventilation is going to include. This is going to be explained. And the transporter efficiency, because if there is no cross ventilations within the mine system, the transportations is going to be impacted. Then how you control the rock, control ground controls and rock support. It is very important that we know that how you can control the ground controls, then the rock support. How will you do that? Because you discover that in the local area where they are trying to do an underground mines, which are not professionally constructed or assessed, you will learn that there's a collapse in some of the underground mines we have across the country that are not professionally done, because ground control is one of the first things that you have to look at. How can the ground hold your support? Column that want to introduce underground. You look at the level of the competency of the rock. How is it able to hold it? Because when you go to some, I was in one of the underground mines in South Africa that has been constructed for past 60 years, and the support that they use, like the timber they use, like the iron they use, they are the one that was designed for that type of purpose. You cannot use a support on incompetent soil, incompetent rock that is going to be sinking. You know, when you use a support on an incompetent rock, they are going to be sinking and it's going to fall from the where it was supported, and they are likely to have a mine collapse. So ground stability is one of the critical aspects of underground design. You have to be how stable it is so that there won't be a collapse. Because it is very important. The technical have to tell you how compatibility will take place. What is the level that we can go that will be able to get a stable soil or a stable ground that can be able to hold our design effectively. So this, and you will be able to know that. That's why it is when the installers are going to ask you, people that are working in it, they will ask, what is the geotechnical result as a result of the test they have done? Because it's just like somebody that went to the aviation school and was on average and you are had to fly a plane. By the time the plane crashed, the insurance people will check the background of the pilot to look at it, that is it an excellent person? Because anybody that's come below 65 in the aviation school are not competent to be a pilot. So at this level, in underground mine, before you can say you want to do an underground mine, you must effectively engage the service of competent geotechnical engineer to look at how competent it is for. Can you hold this support for so amount of years, so that you are not going to put life of people that are working in the mines in serious jeopardy. And you will see that, as I said, support system include rock boats, cable boats, source concrete, steel sets, and mesh reinforcement. I've said it earlier that these are some of the necessary support systems that you have to do. And the vertical strength relationship, you look at it, those are some of the look at the ground control and rock support. And you will see that rock boats and cables, those are one of the things they use. steel set. These are one of the things they need that's required. Then substrate plus mesh. These are some of the things that can bring our support system very well. Then, I've discussed earlier that an adit is one of the things that is horizontal, near horizontal tunnel drivings into an inside to provide direct acid ventilations and natural drainage into the underground. Ventilation design, how do you design ventilation and underground? Firstly, you look at this diagram that I showed, let's like, so you look at this underground ventilation system. So you look at this, that's a contaminated air out. Then you bring the fresh air in. That is fresh air in, contaminated air, that is has been mixed with gaseous. Because at times we use methane, if it is there is need for you to do drilling and blasting underground, and there is going to be a contaminated air. The ventilation have to design and how this air is going to go out. There is a different outlet. This contaminator has reacted with these different gases and all other things that underground. Then they have to introduce the fresh air so that people will not suffocate. And ventilation system supply fresh air and remove dust, heat, and toxic gases, diesel emissions. Then you are using drilling, you are using diesel. You are using toxic gases as is being coming up through the combustion process of, when you are using generator or you are using something that is really is a combustion process and gas exchange will happen. Remove dust and heat. There's a generation of dust when you are drilling. Main component includes fans. That is the ventilation. When you are designing, the main component of ventilation, the ventilators, contains fans, airway ventilation, raises, regulator, and stoppings. Because at any levels is a mechanism that has to comprise of fan, airways. It is something that they are going to create like this thing, that they are going to create like pipe. And some of us, they have, when we are cooking in the kitchen, there is a furnace that is taking your heat out from your. These are examples of ventilation. Because in most kitchen, that's why you go to some home. In most kitchen, they are going to open door to the dining, which is purely unprofessional because all the smell of the food is going to suffocate the entire house. But because you don't have ventilator, this is the simple way of ventilation. So when you are underground, you must be able to do something like that as you're going to be taking whatever you are doing there and introduce another thing. So like my kitchen I design in such a way that there's a ventilator. When they are cooking in front of it, you regulate it to the temperature you want. Then it's going to take it and then you on your AC. The AC is going to supply you the cooling, but this thing is going to carry it in front of your pot. And this is the same ventilation of the ventilations. So good ventilation improves safety, comfort, and productivity on the ground. If some people, they don't like cooking in the kitchen because there's no ventilator in your kitchen. So you say, I don't like to cook. You don't run out of the kitchen. But if your kitchen is done like your bedroom, there is a TV, there is AC, and this one is going up cooling from one side. I won't cook. Let me cook. So you even love to go to kitchen to cook. So these are some of the things that you're planning. When you are doing underground, like the ventilations are their main and have to be considered. Underground haulage system. You see, it is very important that you consider gradient. You remember that at the earlier stage of these trainings, I said the gradients 1 to 7 and 1 to 9 are the maximum gradients that you must have to do when you are considering the planning of underground transport system. That is, we include truck where the truck will be going conveyor, rail haulage, and skip in the south. because you don't do it to be too steep and you don't do it to be too levels, because at the end of the day, if you do it to be two levels, you discover that from outside you are going to be have flooding that is going to overflood your distance, because you must raise the upper part above that no water should be able to come directly, and at the same time when you are going in, you should not let it be too steep that when they are coming out or coming in, it's not going to be. So I've said between 7 ratio 1 to 7 and ratio 1 to 9 are typical gradient range when designing the underground. And I've told you earlier, gradient is calculated by vertical rise over horizontal distance multiplied by 100%. It's going to give you what you need. So in the next series of episodes, we'll be able to tell you how you can actually make use of this ratio 1 to 7 and 1 to 9 appropriately in your design modifications, because it is very important. Once this one is wrong, then how you can plan your transport system underground is going to be affected. There is no such way to it. So you skip you see how it's coming toward the south, and now you can skip it down and compare when it are coming underground. This is when they carry it from the south, they take the body recovery, they are going to go up. You see how it was done. Then the water system, that's one. The water control system prevents flooding and ground weakening. It is important that we should reduce the level of concentrations of water within the underground, because himself is at the water body. For you, you must make sure at every hours to empty the water within the mine. That's why you have to use a control mechanism how you can move out your waters as the water is being stimulated, because at any length you must have gotten to the water table where the water is consistently coming from underground waters. So you know the geologists, when they got on the report they are going to give to the mining engineer to decide, they will have said at any level are going to encounter ground water. They give you that this also level when they are doing their geophysical as part of geology, hydrology. They tell you that. So now you have to create a waterway to control the assumption and this one that already prospecting that they are likely to go, that you now design how it's going to be empty. And this one also have to be in gradient design, because it's not something how the water is going to be flowing genuinely without any other, because you know this one is involved gradient as well. If the gradient of fluids, the laminar and the storm flow was not in order, we discover that water will still going to be coming back to the mine. And this is, if you don't control that one very well, then you are going to have, because at that level, it's going to be still down. If you didn't allow that, and the water is coming back, the mines is going to be overflow. And when there is a flood in the mines, the weak support system is a danger. No matter how level of competencies of the soil of the rock, if the water is just flooding all the time, it's going to make the assumptive competence that you have discovered to be weak and can cause eventual mine collapse. So it is very important that you design a water system to prevent flooding and ground weakening, so that we consistently maintain strong ground system, so that at any level there is not going to be a collapse. Then you know, drainage system include sump, pump, and drainage galleries. You know, when you have empty your water, it's not every water you are going to empty directly to the river. Most of them you have to treat it because of contaminations that already coming from. These are part of the design. The empirical indications of this is that some of them are already, oxidation has taken place, chemistry already taken place in this water, because it has formed with maybe the extractions of particular mineral of target, must have dissolved into this water. And when you look at the chemistry within the body system, they may be very, very dangerous to our system. So you have to look at it very well. If you have to create something we call sum, and sum is where you are going to treat this water. If it doesn't contain some element of mineral, you treat it in the sum before you empty it into the nearby water. Don't forget the aquatic that are inside this water, the fish and all other ones that are there. So if they get this water, it may poison them. And immediate environment, and these are part of the environmental impact assessment, have to be conducted before they look at the chemistry of what you want to do. Then they look at the water. That is biologically all the animal around must not be affected, including the human being living within the food. The water should not be at any levels. So if there is nothing you can do, so you have to create another artificial way of the water for people living in the village. So it is very important that at any level when you see this type of things, you expect them to create a sums. Like if it is gold now, it is the underground gold mine. That's the process of deep water going out must have contained some gold. So you have to do another recovery in the sun through the carpet process or whatever, now to filtrate now to get your gold as a sediment. Then at the same time, when you create a pump, in some cases you have to use pump to pump the water out, depending on the terrain. So it is very important that you take positive dams adequately, the water system, schedule how you can move the water out of the underground. Then, we have the schedule and production planning. In your underground mines, it is very important that how you schedule your production planning is going to be encapsulated into the transport system. And that is the reason why there must be a proper layout underground. Because this one will be able now to tell you that, okay, you have done this, you have done that, then production scheduling planning. How many do you want to produce in a day? What is the upgrade of this? Then production target, equipment allocation, and life of the mine. Before you start even to grade staff, audit, wins and rains, any other thing to access your mine before you started spending money. Lifetime of the mine strategies must have been created from the feasibility that the geologists have been able to establish. Then you do your calculation with economics on the other side, geology on the other side, then all of you now combine, including the mechanism, including the people you are going to use. Is this project that I want to embark on, is it viable or not, before you can now even start at all? You have to define the sequence, the production targets, equipment allocations, then life of the mine before you can now do whatever you want to do. It is very important that summary and closing notes. Before you are even done that, as I've said earlier, there are some software that are very essential when you are designing an underground mine. As I've said, the only way to go that these days is to be digital in anything you want to do. Is to be what? To be digital. And what is important that you know the software as well. Even with geology, you can collect the data. If you don't know how you can run it with your software, then you are back. You just going to be collecting data and you not be able to efficiently and optimally be able to get results of what you are doing. So at this level, we have this way as one of the viable software in designing that underground. The Tankwa School of Mines, Ghana, they have it very well. They are using it. So if anybody wants to use that, so I get the contact of the person that under that. Then the data mines is a popular mines that are just used to do a elementary type, but this week is very, very advanced. Then SOPA is what is applicable everywhere. That you can use it to do whatever. Then leave from Geo is another one, and the voters. They are type of the software that are essential and put in place You cannot use only one. There's many. You use another one to design the system there. You use another one to secure the production. You use another one that's going to help you in doing the ventilation as well. So it is very important that submarine and cruising underground mines combine all body evaluations, mining method selections, access design, ground support, ventilations, always as a building to achieve safe and profitable mineral extractions at depth. So at depth means at a depth already ascertained. So that means that what's necessary only is a building to achieve safe and listening. Then I believe we are speaking to an enlightened mind that wants to know. Thank you very much for listening. Thank you.
Thank you very much, sir. We appreciate the knowledge you've shared with us today. Thank you for the expertise. Thank you for your time. Thank you for always being there for us, for sharing valuable knowledge with us in the industry. God bless you, sir. As we all know, learning is more effective when it is interactive. And this brings us to our interactive session, where we take in our questions, and then we have our facilitator respond to our questions. For those that are here physically, kindly raise your hand if you have questions. And for those virtual participants, please type in your questions on the chat box, and your question will be attended to. We'll be taking a few minutes to wait and receive the questions. This is time for question and answer. Type in your questions on the chat box, and we'll attend to those questions. Also, to virtual participants, you can also tap the raise your hand button in the Zoom link, because you can also speak. You either type in the chat box or you raise your hand. All right, we'll be having a question from one of our physical participants here. We'll start with that. Let's have a minute.
By looking at the education system, decided where the education is going out. Is it just a open door idea where the
Yes, there is a divide now. We just I will say we've gone to barber shop. It's already so there is another set of things that is going to be shocking it. That's one of the reasons why when you have Boeing, you go to the airport, when you see Boeing, don't move closer to the engine of Boeing. Boeing shock. It will shock you. So if anybody close to the Boeing engine, that's this thing like this. You don't move closer. You don't even allow people. So that's why they always put it up before the car. Even if it's Boeing, it is going to shock. So now it is an automatic system. The air that is inside, and that is why we call it ventilation. During the COVID, they introduced a lot of ventilators for people to be able to breathe. So you get it. So this one is going to, when they put it, when it's already installed, it's going to automatically inject the portion of air. Then we are going to create another channel bringing fresh air. As this one is going out, fresh air is coming in the pathway, but it's not going to replace the same thing. That is what the design will tell you. So by next week, I'm going to applications. We are going to know that in most cases, the ventilation where the poisonous gases are going out will not be in one place. It can be true, it can be clean. and the fresh air coming in will not be one. So it depends on how big your underground mine is and the type of material you are trying to work on. So if the type of your material is the type that is have inhaling issues, shocking people, then you have to create a lot of ventilation. Are you getting it? Or you are going to be carrying your oxygen at your back. Because these are some of the things that when you are working in standard underground mine, they always do a life insurance. Because now you are working with coal. What are the things that are associated with coal? You are working in dust environment. See, policies, what are the ones that was a large problem? They always have a particular life to spend that anybody working underground mine, you have not to maybe 10 years max, you have to quit the place. The standard because it's going to shut your organ down. So at that level, see, in some of the, I remember when those days was good when we were working in Quarry, despite we are inhaling some dust and some ammonium nitrate, when we finish, they will give us milk. Fresh pig meat, all of us, we are going to drink because they knew what this thing has caused in our body. When you are exposed to ammonium nitrate, it's going to cause headache. Even the mixing is going to cause headache, not to talk of high explosive. Then the dust that we generated as a result of fragmentation of the rock that we do, we inhale it. That's why we use nose mouth. If you can only cover minimally, it cannot 100% prevent it. The nose, this thing they are doing is only minimal. It's not 100% it. You just like you do something the same 99. No, perfect system is not available. So when we finish every blasting like this, we call the people they are taking it. They give us the thing they are giving us. Some of the people go and sell that meat. So you get it, they will not drink it because the people that are giving it to them because they know the answer they already push us to. And they are going to get a lot of their own bank account. But your own life is going to be short, your lungs is overworking because it's featuring a lot of things. That's why when you look at it, you have the liver cirrhosis. It's not everybody that is drinking, you have liver cirrhosis, you have cirrhosis, you have some people that have throat issues, you have a lot of things that are very deadly. So one thing that is an important complaint like that was standard mind. They give you the maximum time you can be in the mines. Because they will give you no way, because you can't go beyond that. Despite that, your life is shortened. So they give life insurance, they give a lot of things people that are doing it. So it depends on the type of minimum you are working.
Thank you, Sam, for that eye-opener. I'd like to take questions from our virtual participants. I have 3 questions here. The first one, sir, is what factor determines the size and spacing of underground openings? I'll take it again, sir. What factor determines the size and spacing of underground openings? The second one, sir, how do you determine the most suitable underground mining method for a particular ore body? I'll take the second one again, sir. How do you determine the most suitable underground mining method for a particular ore body?
Okay. The factors that determines what the size and the spacing of this. Okay. I've said earlier, all body geometry determines the space. You have to understand the all body geometry, how it goes, what is the length, what is depth, what is the thickness, grade, distribution. And those are the ones that determine the spacing. So then the other part, the method to be used, then you have to consider the grade of that particular thing you want to work on. The minerals are not of the same grade. There are some that you cannot expose into it. Otherwise, your effort is going to be futility. So the nature of the minerals and the ore body in line with the oil geometry determine the method you are going to use for your underground. Are you going to create as it, or are you going to use shaft, or do you want to use ram to go into it, or decline method? So the natures, the formation characteristics, the strength, the raw competency, depth and grade continue to determine the size and the method you want to use for underground.
Thank you, sir. I don't know if you've seen that. How do you determine the most suitable underground method for a particular ore?
I've said it.
Said it. Okay. The third question, sir. How do one monitor ground stability after mining operations begins?
How do you manage?
How do you monitor ground stability after mining operation begins?
Yes, because initially the geotechnical people already did their job. They have given us the informations and advice on the type of work we can do to develop. However, the soil sifted, the ground sifted. At any level, you have an instrument to monitor the foundation. So at this level, that's why there was they gave me one job in this Calabar, the cement factory, Unison, where the village around that place is experiencing a crack. So it has been done before the establishment of that this thing. You have to ensure that the number, if it is drilling and blasting, you ensure that you did not overload excessive use of explosives. No matter the precaution they have given to you by geotechnical engineer, if you are exceed your threshold, it's going to sift the base. So what we do to monitor, to ensure, just like the periodic examinations of physical body in the hospital, they give you cover, don't hit this thing. Despite you are confined to that instruction, there is a need for regular checkup. There is an instrument, seismograph, that have to be with you as it is progressing to still see, are we on course? Because you must ensure high level of safety when you are working on that. Because a simple lapses can end the entire system. So at any rate, there is an instrument you are going to be using it. I went for a course in South African design, mine design and underground. They are telling us we have a support system that are using 60 or 70 years. So when we got to that place, I now asked the question, what is you knew that this thing that they said? In my life of the thing that they use is 100 years. Because you have to consider, you don't use normal iron when you come to an underground. Or you want to use, if you want to use timber, these are the timber that termite have most effect on. The lifespan of that thing is already 100 years. So when it got around 80 years, they will try replacement. You see the difference? 20 years ahead of the time, they are starting doing the replacement. So also when you are doing this thing, if they give us 5 milliseconds as this thing we have to be doing to maintain this ground stability, we don't go beyond it. Like equipment fluctuations. If they say don't use too heavy equipment under the mine, don't use it. Because those are the ones that change a lot of calculations. They said building a bungalow. You say get out. You started building a duplex. That's one of the things that kill us, particularly Africa, where I not operated. If they said they designed this underground for just only 2 trucks to be going and coming, don't introduce different, if articulate trucks are not designed to be moving at that underground, don't use articulate on that. Because they have advised on it. At the moment you cross call, the levels of the advice given to you for the safety, then now you do it. Another question.
Some questions are still coming in.
Okay, wondering if there's any compliance with this to ensure the publish system and ventilation efforts with all this time. That in Nigeria, using the compliance but ensuring that the publish system and ventilation is part of the mind.
There is a compliant body. You are going to set up a compliant body for yourself. I used to say to some guys around that you have password on your phone, but you yourself you don't have password. It's free Wi-Fi. You carry your phone like this. I cannot have access. But anybody can have access to. You are the compliance of yourself. Every mine has a compliance officer, which is mine engineer. But how are you now carefully obey the compliance officer is another case. I said, don't bring paper, don't do this. How many people for Angela, write the name. You didn't write the name. It's a compliance officer. Where is it? So we have at every mine there is a compliance officer, safety officer. If you don't put your all PPA, they will not allow you to in a standard mine. Even if you are a visitor, they will not allow you in. But some people say, oh, they are my friend, they are my friend. And unfortunately, they may blast. During the visit of your friend, there is a what you call fly rods that come down there and hit that person. Then you will not say that you are the one that now saying is my friend living. I was working in Quarry as dated as 2008. Here, today I did we did a blast in nearby village, that is Katampetu. There is a fly rock and it enters somebody's house and it kills somebody that's sleeping on the bed. Break the head. So that is one of the assets when you are doing a design and surface mine and movement. You must get an adequate distance to the mines. You don't build close to the distance. There's a case in Ondo, which I was called upon to do. An estate, and the quarry just around 750 meters in the estate, owned by the Chinese. They have created a lot of crap in the estate. In the first instance, they don't suppose, if they license them, the mine inspector, which are compliance officer in this country, was not supposed to allow them to work. Shut down. And if they decided to be using chemical to blast their rock, you know that the way you can use chemical, the half-life of chemical cannot be determined. So you cannot use any rock using chemical to blast, to do construction or to do road. It's going to fail because do you know what they mean by half-life? The half-life you cannot determine is what you are going to be reflect in physics. The half-life you are going to be the integration process of radioactive element. At any level when you see half-life that cannot be able to determine, then that is what the chemical is doing. If you're using an explosive, it's creating an energy within the rock cavity and do an explosion, and the half-life finish there. But type of chemical that is going to work within the rock overnight is still going to stick into that rock. And if you use it to build house, with time it's going to give way. So anything rock they use chemical to do the plastic cannot work. So that's why all the things that you do that you don't use it, you don't use chemical, you only use chemical to destroy something that doesn't go out of it. Any question? I don't know what question so that this is
So we have two more questions from the virtual participants. how do you conduct a quantitative risk assessment for slope stability?
You know, it's a very simple one. You conduct a quantitative risk assessment by ensure that the gradient you already have for stability, you have to look at it. It's not going to be more than 1 to 7 or 1 to 9. So, and that is slope stability, you have to ensure that you don't go beyond that. And the risk assessment, you have to qualitative, you have to ensure that it's within that. Use your calculation well. Qualitatively, use your calculation well. I don't know if you has this question. So it is, you use your calculation well. So if you don't go beyond what the gradient has to say, that is slope stability.
Thank you very much, sir. I'll take the final question. How do they conduct drilling and blasting underground?
There's no too much difference. It's only the loadings that you have to control. The loading of the explosive that is going to be drilling and blasting as they are, you put the Venga, but there must be a certain level. You don't put the quantity of explosive used for solving on that one. It must have been an agreed calculated one. That is not going to have a lot of necessary factors. Because if you load it too much, the environment area is going to be shaken. I think our capacity about 2 or 3 of that on that one in South Africa. So you calculate it, and those are some of the areas where the mining are very, very efficient. If it is 0.2 you are going to use for your money, you must use it. You don't assume that 0.2 is the same thing as 0.5. No. And the system of blasting is not the one you are going to be blasting towards the pillar. No, away from the pillar.
Thank you to everyone who has participated in our question and answer session. Thank you for contributing to today's training session. Special appreciation once again to our facilitator for providing detailed and insightful responses. As we conclude today's edition of the training, I'd like to encourage everyone not to allow today's learning to end here. The true value of this knowledge lies in applying it to solve real problems. It lies in applying it to our day-to-day work. And on behalf of the management, I was just wrapping up. I got to know that now there's a question on YouTube. Please, can you read it for us? There's a comment. Okay, please, let's take the comment.
Okay, thank you very much, sir. He said, well done, sir. Okay, it's actually a question. Do you think underground mining is still lucrative in Nigeria today?
Okay, it's lucrative because you have not even seen one that did well. And you know, in Nigeria today, there's only a dollar that have done what I can say a full exploration because it took them a long year before they complete it. So you cannot do underground mining or any proper mining without an adequate exploration. You must do your eventual and adequate exploration. When exploration is not done, you cannot take the work time.
Thank you so much, sir. Thank you, everyone. On behalf of the management of Geocardinal Engineering Services Limited, we appreciate you again, sir. We thank you. We thank all the participants, both virtual and physically present ones, for your participation. Your feedback will also help us improve on future sessions. We'll share the feedback link later. We look forward to seeing you at our next technical training program in the month of August. Thank you for your time and attention. And on this note, we'll be wrapping up today's session. Thank you and God bless you.